One of the major challenges with building high-performing machine learning systems is keeping those data-hungry accelerators well-fed with data. We all know how powerful those accelerators are and the tremendous amount of computation that they can do. But if you can't continuously deliver your datasets quickly and efficiently, those accelerators will just sit idle. So today, we're going to talk about Grain, a Python library designed for reading and processing data for machine learning training fast. While it's primarily optimized for JAX, its flexible design allows it to be used with other machine learning frameworks as well. Grain offers a declarative way to define and chain together data processing steps, simplifying the creation of complex input pipelines and abstracting away the complex parallel computation logic needed to make it all work. A number of key principles and features make Grain stand out. First is the flexibility to implement arbitrary Python transformations within data pipelines, allowing for highly customized data preparation. Second, like much of the JAX ecosystem, it's deterministic. Grain's design ensures that multiple executions of the same data pipeline consistently produce identical output. This is crucial for reproducibility, debugging, and consistent experimental results. Third, and this is a personal favorite of mine, it's resilient to preemptions. Grain is designed for easy checkpointing and seamless resumption of data processing after interruptions, which makes it perfect for long-running training jobs in cloud environments using preemptible instances. Last time I checked, there's still a big discount for using preemptible instances, sometimes also called spot instances. So this can be a great way to get more performance for the same cost. Now, before we dive deeper into Grain, something that's worth noting is that by default, it performs its data processing on the CPU rather than directly utilizing the GPU or your TPU for its transformations. This default choice means that it can efficiently prepare the data on the CPU that then feeds into your accelerators. Now, not all workloads are suitable for this particular setup, so you can change it up, but it's good to know that this is the default arrangement. There are two main ways that Grain defines its data processing pipelines: the DataLoader and DataSet classes. In this video, we'll explore just the DataLoader API, and in the next one, we'll check out the DataSet API, along with checkpointing. DataLoader is a high-level API that pulls together three abstractions: a data source to read raw output, a sampler to define data ordering, and a sequence of transformations of your choice. The DataLoader then handles the launching and managing of child processes to parallelize the processing of input data, including things like sharding and shuffling, collecting output elements from those processes, and providing the final batched data for your model's consumption. I'll briefly touch on each of the three abstractions that the DataLoader uses, just so you have a sense of what it might look like to use them. First up is the data source class. The main built-in data sources that Grain supports are ArrayRecord, which accepts a single list of path-like or file instruction objects, Parquet, which accepts a path within any PyArrow supported file system, and TensorFlow datasets, or TFDS, which provides an easy way to load many common datasets. Finally, you also have the option of creating your own data source. However, this path is not for the faint of heart. You'll need to ensure your data is pickleable because your data sources will be pickled and sent off to child processes. Furthermore, we want to ensure that the open file handles are closed after use. Personally, I'd stick with one of the built-in options if you can, unless you're really interested in file systems and data protocols. If you want to learn more about these options, I've included links in the description below. Okay, so we've got a data source. Now we need a sampler, which determines which records to read next. While that might sound simple, as your needs get more advanced, the complexity of this task becomes higher and higher. Some of those considerations include shuffling records across the entire dataset, which might be huge. repeating the dataset for multiple epochs, and sharding across multiple machines. Luckily, Grain provides an index sampler class that we can use to handle most of this work for us, and we can simply declaratively state what kind of shuffling, repeating, and sharding we wish to have. So for large-scale machine learning, this is so handy. I, for one, would not want to be responsible for implementing consistent, reproducible sharding and shuffling across multiple machines. Finally, it's time to talk about transformations. You'll probably be most interested in the map, flat map, filter, and batch transformations. The map transform does exactly what standard Python map does. It maps your custom function to every element of your dataset. Flat map, on the other hand, is for when you want to split up individual elements of your dataset into smaller pieces. For example, say if you had a list of pairs and you wanted to make each pair into 2 distinct elements, or if you had a list of dictionaries and needed to turn that into a list of just all the values in those dictionaries, you could use flat map to yield each element as a top-level data element for your model to consume. Filter is also just like the standard Python filter, where you should return true or false based on whether you want to keep an element in the dataset or not. Finally, somewhat unsurprisingly, batch will help you create batches of your dataset so that it can be consumed by your model in nice chunks. Once you have your data source, transformations, and sampler set up, it's easy to pass them all to Grain.DataLoader to then pull it all together for you. And that's the DataLoader API in a nutshell. As promised, in another video, we'll explore that Dataset API. Even though it's a lower level API, you might like it better. I think there are fewer moving parts to keep track of, and it might feel even more intuitive to use than DataLoader. So be sure to check that out so you can compare them for yourself. So what's your favorite data loading and processing library? Share your thoughts in the comments below. And if you enjoyed this video, let me know by clicking the like button. That's all for now. I'll catch you in the next one.